0.5 big R, then that theory will not work. Okay, so this is so-called a general solution that you can change the value of big R and small r. It will work in most situations. Yes, sir. Yes. Yeah. I'm going to lie down again. Okay. Okay. There's a question behind. So, oh, that question I already answered already. Okay. So sorry. Now remember, this is your time. Okay. Answer. You have the right to answer everything until I drop dead of a heart attack. Not getting it. Homework what? Homework 5. Homework 6. Question 5. Okay. I love homework 6, question 5. It has everything. Oh, the one behind. Yes, ma'am. Okay. Can I do? Yes. Can I do everything? No. Hey? What 6? Okay. Any more? Okay. I will do. Yeah. Yes. Okay. Any more? Okay. So I'm going to address all this accordingly. Any more? No, no, no. Okay. Homework 5, question 6. Homework 6, question 5. Homework. Okay. So at a given instant, the gear has an angular motion shown. Okay, so this is the angular motion shown. Okay. Determine the acceleration at point A. So we have to determine acceleration at point A. We have to determine acceleration at point B on the link. And the link's angular acceleration at the instant. So we have to determine what is alpha AB. Okay, we have to determine what's alpha AB. So from here, okay, determine the acceleration at this instant. There's a hint. Instantaneous center for the link AB is infinity as VB and VA are orientation. Sorry, are parallel. My bad. Okay, not at parallel. Okay. So if we were to look at this, so I think the first thing that we identify is our boundary. I mean, are the degrees of freedom that we see. Okay. So if we look at this structure only, okay? So we know that VB, so we draw a transformation first, okay? We draw a transformation first. So this is X, Y, and this is rotation about Z. And we know that VB is only in the I direction, right? It cannot move anywhere, okay? Now, also another point that we know, at this over here, this is known as our pinion gear, rake and pinion. How do you spell pinion? Is this the rake gear or pinion gear? Could you remember? Rake, right? How do you spell the rake? Okay, so this is the rake gear. And it's given to us, the rake gear is fixed to the ground, so the velocity is equal to what? The velocity is equal to 0. Okay. So we are given what is going on at the wheel. Okay, we are given that omega is equal to what? 6 k radians per second. And because it's going anti-clockwise, it's positive, and we are also given that alpha is equal to 12 radians per second squared, and is also positive in the k direction. Okay. So we want to find what is going on the acceleration at point A. Okay, so I'm going to sketch the gear now. Okay, so we're going to sketch the gear. And we are given that the center of the gear, this is our point O. Okay, so we know that this is rotating in this direction. Okay, this is our omega, and this is our alpha. And we have point A over here. Okay. And I'm going to call this, is there a point B? Okay, I'm going to call this point C. Okay, I'm going to call this point C. So we are going to find what is going on. So we have omega. So we want to find, so what we want to do now is we want to find A of A is equal to A of C plus omega squared cross R B R A from C. No, not omega squared, Eugene, seriously. Alpha minus omega squared R A from C. So I'm gonna start with that. Okay. So R A from point C. Okay, so this is my point C. So this distance over here, so this is 2 and this is 3. Okay. So acceleration at point A is equal to acceleration at point C plus alpha is going to be positive 12K because anticlockwise cross point C from point A, right? So point C, point A from point C. For now, I don't know what they are. I did not determine directions now. I don't know now. Okay. So this, I will get 1J, right? C. So this is 1J minus by omega squared. So omega, we are given as 6 squared. Multiplied by 1J. Okay. So this is A from point A is equal to A at point C plus K cross J is negative, so minus 12I minus by 6 times 6 is equal to 36J. Okay. And is there any more I can do with this? I cannot do any more. Okay, there's nothing more that we can do. So if there's nothing more that you can do about it, just leave this equation and just label this as equation number 1. Okay, because can we specify, question for you, can we specify acceleration at C is equal to 0? Then acceleration at C be equal to 0. I know velocity at C is equal to 0. Right? Yeah, velocity at C is equal to what? Is equal to what? 0. Okay. But if we are not sure, don't make that assumption. Okay. I'm not going to make that, as I say, I'm not going to make that assumption at all. Okay. So the next thing that we do, we want to find the velocity at A, or we want to find the velocity at A. But do we know the velocity at A? Do we know the velocity at A? So what we know, okay, we have to, so if this is moving this way, so we know that this will be our V0 direction. Yes or no? Because as the wheel rotate in a clockwise direction, V0 has to be in that direction. When V0 is at that direction, we're going to assume what? VB is at that direction. Okay, we are going to assume VB is at that direction. Okay. So from here, we can determine our V0. Go on. Can we determine our V0 now? So now I might be able to form. Okay, so let me copy this again. I thought this question is easy. So now if I were to find, if I were to form the equation, now member AB is a rigid body. Okay, member AB. So if I were to write that VA is equal to VB,